Okay, so I'm really happy to do this talk because it was a lot of fun to get it prepared. So I will talk to you about state machines and nice things we can do with them. I'm Pierre Halftermeyer, I'm pre-sales engineer at Neo4j. So let me start. So what is a state machine? We also call them a finite state machine when they are finite, and they will be deterministic finite state machine. They will be deterministic in our context. Or I'll say automaton or automata plural, FSM as an acronym. What does Wikipedia says about them? So finite state machine are a mathematical model of computation. It is an abstract machine that can be exactly one of a finite number of states at any given time. The FSM can change from one state to another in response to some inputs. So we have states, we have inputs, and states change with those inputs. An FSM is so defined by a list of its states, its initial state, and the inputs that triggers each transition. So we have state and transitions. It sounds like nodes and relationship to us. So let's see it as a graph. Here is an automaton for language recognition. We'll call it the LOL language. So how does it work? I will try to find out if the word haha is recognized by my automaton. So I am in the initial state because there is the arrow, and I will read the first letter of my word, H, and that will get me to the state 1. So I have 4 states here. Then with the A, I go to the second, to the state 2, then with H to step 1, then 2 again, and with my exclamation mark, I get to the state 3. It is a terminal state, so my word is recognized by the language, is part of the language. So I have a machine that is able to recognize a word from a set, from a language. And this is the first, say, use case of automata. I need to put those automata in my database because we are working with Neo4j, it's a database, and I'm trying. I need to express them as data. There is a very straightforward mapping from my automaton to a CSV. Here, for instance, the yellow state is the first line, and the red transition is the red line, and we can see it's very easy. So when I have it in a CSV, I can ingest it. I also can ingest several automata in a single file, in a single CSV file. Here I have 3 languages, say the ABC star language, the LOL language, what we have seen, and the Python var language. A Python var is an alphanumerical string that does not begin with a number, and underscore are accepted. When I have several symbols in my transition, you can consider it's a list of admitted symbols for this transition. So we are ready to ingest. To ingest, we can use the Neo4j data importer. It's an awesome tool if you want to prototype a very fast database. So you should use it. And tada, let's see if it works. So I have an Aura instance. I have my state machines data file. My importer, I've already imported it, but if it's really easy, you draw the meta model with transition from state to state, and you can ingest your CSV from a very easy mapping. There is no code. If I do a preview, I see my automata are in the database, so I can query them. I can show you all state machines with a very easy query in my database. They are in my database. Then I can create a word to see if it works. I will create the word as a chain list of symbols. I will init my computing. I need some really straightforward code, and I'll set the language to the LOL language. This is the language against which I will check my word, and I can iterate each state and each transition with code I will explain later. If I want to iterate all state, I put it in an APOC periodic commit, and I have all my process done, and I can check if my word is part of the language, and here is accepted language. When I have it, I can build a tool to check if a word is from a language or not. For instance, from the LOL language, I can check if this word is accepted by this language, but maybe it's not by another one. It's not a valid Python variable. If I remove the exclamation mark, then it is. I can put an underscore at any place, and it will also be good. So I have something functional, a very straightforward way to build an application with a finite state machine. How do I process a word with an automaton? It's very easy. I have the chain list of my symbols and my automaton. The blue state is the current state, and this state is the first unprocessed state. And then, so first unprocessed, current state. So then, as it's an H symbol, I will trigger this transition to this step. And it's really straightforward to write this in Cypher. This is the first unprocessed, maybe the first of all of them, or the first following a processed one. This is the current state. This is the transition that contains the symbol I'm referring to. And this is the next step. When I add this, I can update my current objects really in a really easy and straightforward manner with Cypher. And I use NeoDash for the front end, because it's a great tool you can use for prototyping a front end very fast. So I encourage you to use it. So we can use Automata with Neo4j, but what are they good for? And first of all, I want to share an intuition with you about control flow. Control flow in a programmation language is like structured like for loops, while loops, if then else. It enables you to control the flow of your code. And we can see that some automatas are really close to control flow. This is a while loop. While true, while I see the true event, I stay in my loop, and when false, I go to another state. And this is if then else statement. I have a Boolean value. If it's true, I go to some terminal node. If it's false, I go to some other terminal node. So there is a mapping between automata and control flow structures, and we can build more complex control flow structures with automata than we can do with normal code. Now, what are automata good for? Some use cases. This one is from a puzzle of Advent of Code hackathon. It's bytecode parsing. You have to find packets in bytecode. Bytes are queued in the green chain list, and you have your orange automaton at the center, and you are like gluing state to sequence of bytes to find your packets. There is a link on my GitHub. You can find the code there. Then you can control the gameplay of any game with an automaton, and the automaton orchestrates the gameplay. It's like the referee of the game, and it can trigger any event from where you are in your gameplay. So this is a dice game with 2 players, and you can see there is code in a state. A code is triggered and is inside the state. It's like meta programmation with graph. And I will use this strategy later to show you something. This is an AI problem. I have 3 workers and a toolbox, and I need to get them down, and they are not supposed to die in the process. And you have to find the best strategy to do it. It's an optimization problem. You have to do it in the shortest way. There is the code is on my GitHub too if you want to see. So let's go to a deeper dive in some use case. This is the way I log my workout with my phone. I have NFC chips there, and when I work out, I do deadlift 130 kilos and 3 reps, and it's the way I do. So I can trigger with my NFC enabled phone an event, and I add an event to a chain list. Here I do bench, and I have an automaton to parse this. I can put an iterator on the last event and the current state, and then it can see the next state would be there is no wait anymore because I have changed my exercises, and it has used the transition move, and there is code in this transition that triggers code, and that set a memory to the right values, like move has changed and weights are now empty. I put that in an APOC periodic to reiterate it all, and I can data is not actionable. So what was only some chain of events, I will do it. I will process the data right now. I have an iterator with my state machine and my data, and now I can. Sorry for that. Passwords are sometimes Okay, and now I can see I have reps in my database. I can see all my reps. No, it wasn't. I wanted to show you sets of work. So yeah, I can see I have, for instance, a deadlift set with 3 reps at 150 kilos. So and I can build an app with that in a really straightforward manner. I can see I'm benching this month. Those value 1 rep max was 115 this week. So I have an actionable data from a non-structured sequence of events. So thank you. That was what I wanted to show you. And I don't know if there is questions and if we have time for questions.
Sure, let me just check if we have more questions in the chat window. Just give me a second. Nope, none so far. It was a great session, I believe.
Okay. And I hope I've respected the time. Almost.
Yeah, you're well ahead of time.
How? I'm ahead of okay.
Yeah, we have 3 more minutes.
Okay. So we can play with, for instance, I don't know, Python. There is another language we have not tested. It's the ABC star. It's from the so it has to start with an A and then only ABCs. So it's accepted. And if I put a D here, well, it's not accepted anymore. Okay. Well, you can have an, and I suppose it's also an accepted Python variable. It's the one I use most with foo, bar, and a by d, and playing with my keyboard. And yes, so it's the way I do my. This is the way I do my workout with my phone. NFC chips. You can use NFC chip for a lot of stuff at home. They are really cheap, and you can do fun things. You can put. I put them on toys of my children for their everyday routine to brush their teeth or anything. So it's a nice tool to use for anything. My GitHub repo will be in the slides, and slides will be shared. But my GitHub identifier is my full name. It's Halftermeyer.
Yeah. Would you mind sharing it with me? I can just push it in the chat window.
Okay, of course. There are a lot of windows here. Sorry for
you can
that.
just push it in the StreamYard window.
Yes, of course. Yeah.
All right, I've got that. Let me just push it. Here you go, John.
Then there is several repos about Automata. And
Super, I think we are right on time. Unfortunately, we don't have any questions from the audience. I believe the session was really exciting.
No problem. Questions welcome later if you have.
Yeah.
This is my email. If you can spell my name, you can send me emails.
That's right.
Yeah.
Thank you. Thanks so much, Pierre.
Thank you, Steve.
This is
Thank you,
wonderful
everyone.
having you. Look forward to having you next year as well.
Thank you and goodbye.
Thank
See you
you.
later.
Bye.
See you in next talks.